All right, we're going to take a look at our final lesson video for Unit 1, Day 13, or Day 1.13. We were talking about parallel line relationship proofs again, very similar to what we just talked about for Day 1.12, but now we're kind of getting rid of that algebra part. We're not using the equations, we're going into the little bit more complicated proofs like we had on Day 11. So we're really just reviewing the same material though. Okay, now last time we talked about something called the corresponding angles theorem. It's the same thing as this. They say postulate here, only because we really don't have to prove this. In any situation where we have parallel lines cut by a transversal, the corresponding angles are congruent. That's really all we are talking about here. Okay, corresponding angles are congruent. Okay, and then I've got the other theorems from the previous lesson. Okay, you'll remember last time we talked about these theorems. Okay, and what we're going to do is we're going to actually just quickly look at some actual proofs of those theorems. We're going to prove using corresponding angles that these other angles are either congruent or supplementary when we get down there. Okay, and so there is a little bit of a change to the way that this was originally typed. They use angle measures and they use equals, where we were using congruent angles, and so we're going to kind of fix some of that. All right, and so what I want you to do first is help me by kind of making some changes here, and I'm going to pause the video, make these changes, and then you'll want to see those and copy them down yourself. Okay, in this first one, when we talk about the alternate interior angles theorem, we just changed these measures equal to congruent angles. Okay, so angle 1 is congruent to angle 5, angle 1 is congruent to angle 4, angle 4 is congruent to angle 5, and this is what we're trying to prove. If I'm given, okay, if that given is just that I have parallel lines AB using this picture, okay, all these proofs are going to use this picture, then I want to prove that angle 4 and angle 5 are congruent. Well, angle 4 and angle 5 are alternate interior angles. So I can't use this theorem in the proof. Okay, that's what I'm trying to prove. So none of these blanks are going to be the alternate interior angles theorem. This is not necessarily what you're going to have to do on the assignment, but we are building off of these proofs later on, so we need to actually go through and show the proof of these theorems. Okay? So what we have first is that our given information is that we have parallel lines, and so I want to look at the relationships of these other statements to figure out what reasons I might have. So angle 1 is congruent to angle 5 is the next statement of the proof. If I was numbering these, this would be 1, 2, 3, and 4. So in statement 2, angle 1 is congruent to angle 5. When you look at the picture, 1 and 5 are congruent because they are corresponding angles. So that is your corresponding angles theorem or postulate, whichever one you want to write when you're doing this on your own. Then the next statement is that 1 is congruent to 4. Well, if I look at the picture, angle 1 and angle 4 are vertical angles. And if you remember in class, we talked about the vertical angles theorem, where if we have vertical angles, they're congruent. And so that's the vertical angles theorem. Now, if you look at this, 1 and 5 are congruent, 1 and 4 are congruent. That means 5 and 4 have to be congruent also. And it's kind of like substitution for congruence, but that's where we call this the transitive property. We're going to use that a lot with these. But it's a property of congruence. Let me explain that to you a little bit here. Okay? It's kind of like I'm saying angle 5 is congruent to angle 1, which is also congruent to angle 4. And if you think of the transitive property like a train, we're saying 5 congruent to 1, which is also congruent to 4. So 5 is congruent to 4, or 4 congruent to 5 like this. I could go backwards. Okay, so I can kind of cut out that middleman and just say that angle 4 and angle 5 are congruent. That's a transitive property situation. Okay, moving on to our alternate exterior angles theorem. If we're given that we have parallel lines again, same picture, I want to prove that alternate exterior angles are congruent. So I chose a pair of alternate exterior angles, angles 2 and 8. 2 and 8. I cannot use this theorem in the proof of that theorem. That's like using a word in the definition of that word. You know you're not supposed to do that. So this time we're going to kind of do our own work here. All right, I'm still giving you the first given statement. A is parallel to B, in case you forgot how to read that. That's given to us. But then I want to work towards eventually saying angle 2 is congruent to angle 8. And in fact, if you want to write that in, You're welcome to. Okay? You know that's what our last statement's going to be. And I've given you the right number of blanks this time, so I'm telling you to go ahead and do that. We want to work towards angle 2 being congruent to angle 8, and I've given you a little hint here. I want you to start with corresponding angles. Now, if you haven't copied this down yet, make sure you pause here and copy this down correctly so you know what you're doing with the rest of this. So for number 2, I want to start with a pair of corresponding angles, and one of them needs to be either angle 2 or angle 8. Obviously, 2 and 8 are not corresponding, but 2 would correspond with 6, or 3 would correspond with 8. And the relationship I want you to notice is that if I said angle 2 and angle 6 are corresponding angles, 6 and 8 are vertical angles, so they're congruent. So that's a way that I can set up something similar to this last proof. So that's what I'm going to do. I'm going to pick angles 2 and 6 to start with. I know angle 2 has to be congruent to angle 6 because of this same reason. They are corresponding angles. Corresponding angles, postulate. Or call it a theorem, whatever you need to do to remember it. But I eventually want 2 to be congruent to 8, so this next line needs to connect 6 and 8. Well, 6 and 8 are vertical angles. So I can say angle 6 is congruent to angle 8 by the vertical angles theorem. Well, this is kind of like setting up that train of congruent statements. 2 is congruent to 6, which is also congruent to 8. So if I cut out that middle common angle 6, 2 is congruent to 8 by the transitive property. And it's a property of congruence. Okay, so these next two we are going to save to do in class. We're going to do these together. You can try them on your own if you want. I will tell you we need more blanks in this one. Actually, in both of these, we need more blanks than are given. So that's why we're going to do it in class. So we're going to save those because they're using supplementary relationships. So we're going to get to expressions like that. Okay, so what I do want you to do is go ahead and turn the page and we're going to try some examples together. Angle 1 is congruent to angle 9 by the transitive property. And that's what we were trying to prove. So I didn't even need all the spaces given there. Okay, we're going to skip over number 2 because it uses a supplementary relationship, and we'll come back to that one in class, but we are going to go down here to number 3 and do that one together to finish up the video. Okay, once again, we are dealing with our parallel lines first. A parallel to B, L parallel to M. Okay, and that is given. And I want us to prove that angle 13 is congruent to angle 7. All right, so I've already kind of marked my picture up, but we should be able to see this. 13 I want to be congruent to 7. Well, 13, we need to transfer that down to angle 7. So I can either go to the left and then down, or I can go down and then to the left. It doesn't really matter which way I go. I'm going to choose to go to the left and then down because I'm going to use that same relationship that 13 and angle 1 are corresponding angles. Okay, and so they have to be the same as each other. Well, 1 and 7 aren't corresponding, but 1 and 7 are alternate exterior angles, which have to be congruent also. So that's kind of the way I'm going to do that. So we're going to say first that angle 13, and that's what I start with because that's the first part of my proof statement, angle 13 is congruent to angle 1. Because they are corresponding angles. Okay, sorry, there you can see that better now. But then I'm going to travel from angle 1 to another congruent angle. Angle 1 is congruent to, I'm trying to get to 7. 1 is congruent to 7 because they are alternate exterior angles, which there's a theorem for that. Okay? Well, if 13 is congruent to 1, which is also congruent to 7, that angle 1 is your middleman, it's your common congruent angle, I can just jump straight to angle 13 is congruent to angle 7 by the transitive property of congruence. Okay? Like I said, we're going to save example 2 for in class and the previous 2 proofs on the front page to do those in class as well.